Hello everyone, today I am going to show you how to solve number 38 from chapter 17, Electrical Energy and Power. First, let's take a look at the problem. Number 38 reads, a portable coffee heater supplies a potential difference of 12 volts across a nichrome heating element with a resistance of 2 ohms. Part A asks, calculate the power consumed by the heater. Part B asks, how many minutes would it take to heat 1 kilogram of coffee from 20 degrees Celsius to 50 degrees Celsius with this heater? Coffee has a specific heat of 4,184 joules over kilograms times Celsius. Neglect any energy losses to the environment. The first step of this problem would be to identify the given information. So we know that the potential difference across the nichrome heating element is 12 volts. We know that the resistance of the nichrome heating element is 2 ohms. And we know that the mass of the coffee is 1 kilogram. We know the specific heat of coffee is 4,184 joules over kilograms times Celsius. We know that the initial temperature is 20 degrees Celsius and the final temperature is 50 degrees Celsius. With this problem, we know we're going to be using two equations. The first equation is the power consumption equation, which is P equals V squared over R. And the second is the specific heat formula, which is Q equals M times C times change in T. Mass times specific heat times change in temperature. Part A, it asks us to calculate the power consumed by the heater. So we know we're going to be using this equation. Referring back to our given information, we know V and we know R, so we're able to find this. Plugging in our information, 12 volts. Resistance is 2 ohms. Plugging this in our calculator, we get 72 watts. And this is our final answer for A. Now, part B asks, how many minutes would it take to heat 1 kilogram of coffee from 20 degrees Celsius to 50 degrees Celsius with this heater? So, for part B, we know we're going to be using the specific heat formula. Referring back to our given information, we know the mass is 1 kilogram. We know the specific heat of coffee is 4,184 joules over kilograms Celsius. And we know that the change in temperature, the initial temperature was 20, the final temperature is 50. Now, we can plug this information in our formula. 1 kilogram times 4,184 joules over kilograms Celsius. And to find the change in temperature, we do the final minus the initial. So 50 degrees Celsius minus 20 degrees Celsius. We know that 1 times 4,184 is itself. Bringing that down with our units. And we know that 50 minus 20 is 30 degrees Celsius. Plugging this in our calculator, we get 125,520 joules. Now, part B asks how many minutes would it take. So we know we're going to be using another equation, which means there's part 2. The second equation of this would be P equals Q over change in T. With this formula, Once again, we must refer back to our given information. We just found Q, and we know T. Referring back to the triangle that we were taught, to find T, we cover it and we get the equation Q over P. We just found Q and we found P previously. So to find the T, we can plug in our information. 125,520 joules over 72 watts. Plugging this in our calculator, we get 1,743.33 seconds. Now, our answer is in seconds, so we know we must convert it to minutes. There's 60 seconds in 1 minute, so we would divide by 60 seconds. Plugging this in our calculator, we get 29.06 minutes. This is the amount of minutes that it will take to heat 1 kilogram of coffee from 20 degrees Celsius to 50 degrees Celsius. This was problem 38 of chapter 17, Electrical Energy and Power. Hope you enjoyed the video and thanks for watching.